Oh, no, no, no. You know what I realized? I created literally like almost a 15-minute video and then I ran out of time. So this is the second take, but on the first try. All right, no wasting time. Today, we're gonna build and polish this graph. I'm not gonna get into any tangents, make this a less than 15-minute video. Here we go. I realized, number one, that these cells are somehow corrupted. I don't know, the graph is picking up some weird stuff, and then as I change some things over here, it was changing, so just bear with me. I'm going to change my numbers over here. Now, we're going to calculate some things here just for tomorrow and partially for the graph. So I'm gonna show you something. In order to take a shortcut, we're going to move this data, this array, next to the other array. So click and drag. Click and drag. Let's bring this other one over here. And if I'm talking faster than usual, it's because I might feel rushed that this video will end. I only have a 15-minute time limit for my free subscription. Okay, it's just the details. So this is blow-dried hair, just don't lose track. Red with red, orange with orange. This is non-blow-dried hair. Our table is still here because it corresponds to these numbers. If I were to change them at any point, the table would change. That's pretty cool. So let's put some labels. I'm gonna do this. Well, let's put some labels from here. We're gonna put count. We already have mean, standard deviation, 95% confidence interval. So the next one would be count. We already have mean. I said standard deviation. I'm going to abbreviate it as SD, and then 95% confidence interval. I'm also gonna just shorten it to CI. And last one, but more importantly, it's what we call a p-value for a t-test. It's a p-value of the t-test. This is the most powerful thing because it tells us exactly. See, this table is just changing as I type. Okay, let me see if I can create it one more time. Pause the video. Oh, all right, here we go. Well, let's look at these formulas. I'm going to move some things around because I don't want to be scrolling. If I was using another computer with a better mouse pad, this would be easier, but I'm using a regular mouse and it's a little bit harder to do this and scroll to the side. I'm bringing my my formulas here so that I don't have to be scrolling left and right. So let's begin with count. We're going to start every formula with an equal, count. What? Nothing showed up. Count. Nothing is showing up. Interesting. What about here? In count. Nope. Alright, let me pause the video and fix it one more time. Done. I think it's because I copied and pasted a lot of this information that some of the cells got somehow corrupted. I copied and pasted it from your file to mine, and yeah, anyway. So let's do count, and then I remember the cells being D9, hey, I learned that from yesterday, to D58. Let's see if that's correct. It should be 50. I know that it's 50. But if you double click here, it will highlight the section from here to here. There you go. Perfect. And then we're going to calculate the standard deviation for this. Again, we don't need to know what it means today. We just want to do calculations today. We'll get into the concept of it tomorrow. Standard deviation is equal STDE, and there it is. And then same thing, you select the array that you want to calculate the standard deviation for. That is from D9 to D58, and then 95% confidence interval. And here is where the magic happens. So it's important that you put 0.05. Again, we'll get into the details of why tomorrow. Well, I can tell you right now. Look at how it says confidence interval. This is, we want to make sure we are 95% confident that whatever number we get for the p-value is correct. We could make this smaller, meaning so for now, there's a 5% chance that we are wrong. If we make it smaller, like 0.01, then we're making sure that there's only a 0.01 one chance that we are wrong. So for now, it's pretty standard to use 0.05. It's just like, if there's weak, medium, and strong, this is just medium. So then our standard deviation, which is in cell B32, so I'll put B32, put another comma, so you'll notice 0.05, comma, standard deviation, comma, and then the count, which was in B31. And then we press enter, and that does everything for us. Oh my goodness, this table is just driving me crazy. All right, here's where the magic is. Because these two columns are next to each other, the two arrays, Google Sheets has this algorithm or something that if you hover over this section where the plus sign shows up, click and drag, it does the same calculation but for the other column. Click and drag. You could actually just select all of these and then drag them all, but I'm just showing you one by one that you can do all these. So I'm going to color code this with a gray and just something light, and then color this with, I don't know, yellow, because this shows that this p-value is something that encompasses all the information, all the data in this study. It's not just for one array and the other, but this is a number that tells us how can we compare one array to the other. So our p-value for the t-test, you'll notice here, I can barely see it, at equal t-test. Let's put here equal t-test, and then array number 1. So we need to select array number 1, that is D9 to D58. Then we put a comma, and notice here comma, and then array number 2, that is E9 to E58, comma, 2, comma 2. We'll figure out what those two mean and why they change later on in our next video. For now, we get our value. Perfect. It's 0.01. That's good. All right, let's polish this graph by inserting some titles, some labels. Let's go to charts, axis, and titles, and put the title here. Probably, you know, what is this about? Let's scroll up. It has to do with hair, hair, and physical strength, characterize protein. I think it's just, we'll title it the breaking force of non-blow dried hair. Okay, I'm gonna pause and then come back. So I put the title as breaking force of non-blow dried hair versus blow dried hair because we are comparing those two. Somehow I feel like I'm gonna have to do something here. Why is this B39? What? Okay, I'll pause and fix this table. Okay, I got it. Breaking force of non-blow dried hair versus blow dried hair. Let's go to vertical axis and put here, well, what does these number mean? Is it 2.0 cows? Is it 1.5 gloves? Well, these numbers, these units represent the mean breaking force in newtons. So that's what it means. And finally, I'm gonna go to series and do the final portion here. This is why it was important to change it to a lighter color. So we're gonna select the non-blow dried hair. And we're gonna put some error bars. And it's important to put a lighter color so that it's more distinguishable. You'll notice that with a darker color, the error bar doesn't have much contrast. So change this from percent to constant. I'm going to sneeze. Can you imagine if I was a streamer, like sneezing in mid-stream? Okay, here we go. Constant. Let's take this 95% confidence interval right here and insert it here. 0.118. We want to put as many digits as possible to be as precise as possible. 3, 5. 2, 8, and I'll keep it there. And then we'll go to the other one, do a lighter color, error bars, change that to constant, and put that other number right here, 0.228082. 28082. Great, 1, 3. Okay, it's getting a little bit frustrating. I feel like somebody is like hacking my laptop. My mean changed out of nowhere, and these two means look pretty similar. But finally, we are done. So what does this mean? See, to the layman, to a regular person, if you ask them, is the tensile strength, is the breaking force different? Like, is non-blow-dried hair stronger than blow-dried hair? Anybody would just say, well, yes, of course. And if they dismiss the error bars, well, definitely they would say, yes, of course. But if we were to zoom in, what we would see is that they're not that different, especially with these error bars. Imagine this. If there were two ants fighting, to them, like, they may be like a bully versus like a tiny ant just fighting ferociously. But if you had an elephant view, they would look just as small to you. And that's what it is. If you look really close, you can see that they may look different, but upon analysis, from like a bird's eye view, and we can do that not by changing the graph, but by inputting these error bars and running a statistical test, we know that yes, they are different, but they're not different enough. See, when these error bars overlap, and that is seen more clearly if I put some grid lines here, major grid lines, minor grid lines, I think it's a little bit more clear that these two error bars overlap. If I were to draw a line from here to here, it would fall in that space for this other error bar. It doesn't go from here and then land here. So because the spaces overlap, it means, well, there's evidence that tells us that non-blow-dried hair is stronger, but it's not very strong evidence. And so perhaps perhaps there are some outliers in the data. Perhaps you grabbed 50 hairs that didn't correspond with the true strength of non-blow-dried hair and blow-dried hair. So there are some errors, and they just happen to be by chance. So what should we do? Pluck out more hairs. We need a bigger sample. Basically, that's what it means. It doesn't mean there is no evidence or there is enough evidence. It means, look, the evidence is not strong enough. We need more evidence to make it very strong and very convincing. And how do we do that? The solution is almost always get a larger sample, because what these error bars are doing and what the t-test is doing is we are assuming that these 50 samples are representative of all the hair that a person with non-blow-dried hair has. We are assuming that these 50 samples are representative of all the hair from a person who blows-dried their hair. But there may not be. It's possible that we got hairs from a place in their scalp or their head that is not representative. Maybe it's a place where they tend to blow-dry their hair more often. Or, because like, who blows-dry their hair like in a uniform manner? You just kind of go, I don't blow dry my hair, but I'm just saying. All right. Thank you, everyone. So our conclusion, they are different, but the evidence is not strong enough. What do we need? We need a larger sample. I'll see you tomorrow.